Hey everyone, I'm Shah. This is the fifth video in a larger series on AI agents. Here I'll explain the Model Context Protocol, or MCP for short. I'll start by discussing its key concepts and then show you how to build a custom MCP server with Python. At this point, you've probably heard the term MCP before, but maybe you aren't super clear on what it actually means and why you should care about it. But all MCP is a standard way to connect tools and context to AI applications. So this is a standard developed by Anthropic, and the analogy they use to describe it is that MCP is like the USB-C port of AI applications. Just like how USB-C gives us a universal way to connect any device to, say, a computer, MCP gives us a universal way to connect external tools and context to AI applications. There are many benefits to having this open standard for connecting different AI components together. But just to list a few concrete examples, one, it allows users to port in custom integrations into their AI applications. For example, I might want to connect Slack and Google Drive to Claude so it can get context from these external apps, or even write messages to a particular Slack channel. Another benefit of MCP is that it enables you to have these portable tool sets. So let's say I've locked in my AI coding assistant development stack, and so this includes things like boilerplate code, different prompt templates that are really helpful for debugging, or maybe some custom tools of creating automated documentation or something like that. MCP allows you to create this tool set just one time and then dynamically port it to whatever IDE you like. So let's say you were on VS Code for a while, but then Windsurf came out and you wanted to give that a try. You don't have to start over from scratch. You can just take your tool set and go from 0 to 1 very quickly. The final example I'll talk about is, let's say you ship your own custom AI app. You can benefit from the rich ecosystem of open source MCP servers to increase the value of your application to your end user. All you have to do as an app developer is to create an MCP client, and then immediately it allows your application to connect with any number of MCP servers developed by third parties. So this might all sound well and good, but you might be wondering, how does MCP work under the hood? So the architecture of MCP is actually very intuitive. It follows this client-server architecture, which is widely used in the web space. But the basic idea is that you have two modules. You have a client and you have a server, where a client sends requests to a server, and then the server generates responses to these requests. This is just like if you were to go to a coffee shop. You or anyone going into a coffee shop are kind of like the client in a client-server architecture, and the barista is like the server. So the client will send a request to the server saying something like, "Can I get a pumpkin spice latte?" And then the server will respond, "Yeah, you got it." So mapping this analogy to MCP, we'll have an MCP client, which is kind of like the customer at the coffee shop, and an MCP server, which is kind of like the barista at the coffee shop. And the client will send requests to the server like, "What tools do you have available?" Or "What resources do you have available? What prompt templates do you have available?" And the MCP server will respond based on its capability. So if it just has one tool, write email draft, it'll respond with that. This is just like a high-level overview of how MCP works. Let's now dive into each of these two key components. First, we'll start with the MCP client. These components are built directly into AI applications, and they're the ones that send requests to MCP servers. For example, suppose we're working with the Claude Desktop application. Claude Desktop actually has a MCP client built into it. So when you're using the application, you'll see the various tools and integrations that are available to Claude in the user interface. So these are facilitated by the MCP client, but the client is getting access to these tools and integrations from external MCP servers. This isn't just limited to one MCP server. You can have any number of MCP servers connected to a single client. Some of the things that the client is responsible for is that it'll discover the server capabilities, kind of like what we saw on the previous slide. The MCP client will ask the server, "What tools do you have available?" Another key responsibility is receiving data from servers. The MCP server may make available to the client a a database or a file system. So it's responsible for grabbing that data and passing it to the LLM application. Another critical responsibility is managing the tool execution, because of course LLMs are simply text generators. They're not capable of executing tools themselves. This needs to be done by another piece of software. So the MCP client can handle that. And an important note here is that, if you're using an AI application, you typically won't need to implement your own MCP client, because these libraries and applications will already have an implementation of it. However, the thing that you might need to develop more often is the MCP server. So diving into that, as we saw in the previous slide, the server is an independent system from the AI application, and it's responsible for listening for requests from MCP clients and responding appropriately. Returning to our Claude Desktop example, we can have our independent MCP server living over here, and it's talking to the client. And some of the key primitives in the MCP server that gets passed to a client are prompt templates. Often you have some boilerplate prompts. For example, if you have a prompt that works really well for you for rewriting your resume, and you just want to quickly swap in and out a original version of your resume and the job that you're applying to, you can frame this as a prompt template and easily swap out those two inputs. Another key service are resources. These can be like static data files, they can be entire file systems, or they can even be a traditional database. Resources are very similar to GET requests. Basically, you'll send requests to a external service, and the service will send you back some specific data. And the key thing about resources is that they shouldn't be computationally expensive. It should just basically be a lookup of some data that gets returned to the MCP client. And then finally, we have tools, and these handle basically everything else. Tools are arbitrary functions that allow the MCP client to perform actions. So this can be like any Python function, accessing an API, or even doing things like image processing. And the last thing I'll say about MCP servers is that there are two default ways we can transport information between the client and the server. The first is the standard IO. So this is great for local development. Basically, you can have a local application like Claude Desktop, and then you can spin up a server locally, and the server and the client can talk to each other via the standard IO. However, if you don't want to have everything running locally, maybe you want your application on the cloud, then you can spin up the MCP server via HTTP with server sent events, so SSE for short. And so this allows you to basically have the client and the server talk to each other over the internet. The discussion so far has been pretty high level and just talking about conceptual things. Let's make this concrete by implementing a custom MCP server with Python. Here I'm going to use Anthropic's official Python SDK, and the link to that is available in the description below. The server I'm going to build ties directly to a project I built in a previous video of a series where I made an artificial virtual assistant called Ava, who basically was capable of taking requests from me and performing various administrative tasks, whether that's drafting an email, reviewing contact information, and other things. Like we saw there, Ava was able to do these things because it had access to a set of tools. It had a tool that allowed it to write drafts in my Gmail mailbox. It had access to a directory of common contacts, and it had access to some common email templates that I would write. So the power of MCP is that if I take this tool set and wrap it in an MCP server, then I'm not just limited to that single implementation of Ava. I can just as easily take these tools and port them to Claude Desktop or to Cursor or to any application that has an MCP client built into it. So let's see how we can implement this with Python. The first step is to install UV, and if you're not familiar, UV is an extremely fast Python package and project manager written in Rust. However, the reason we want to use UV isn't because it's super fast, it's because it gives us a way to manage the entire Python Python environment necessary for running some code. We'll see why this is helpful a little later, but the short version of it is that since UV kind of handles all the environment stuff, we can spin up the MCP server with a single line command. So if you don't have UV installed already, this is from their documentation. So you can install it on Mac or Linux using curl, or you can install it on Windows using PowerShell. Next, we're going to create the server. And so this is super easy using Anthropic's Python SDK. We can just import this fast MCP class, and then we can create a new MCP server called Ava with this line of code. Before, we saw the three key primitives in an MCP server are prompts, resources, and tools. So let's add each of these to our server. We can add a prompt in the following way. We'll basically create a function that takes in text inputs and returns a string output. And all we do is add this mcp.prompt decorator to the function to make it a prompt. Here I'm creating the global instructions for Ava. So we can see it says Ava artificial virtual assistant. You are Ava, a virtual assistant, to insert username, insert user title. You help them with administrative tasks, and then there are some additional preferences. Basically, this template will take in the user's name and title and dynamically plug it into this prompt so it can be passed to any LLM. Next, we're going to add resources to the server. We'll do this in a very similar way we created the prompt, but instead of doing mcp.prompt, we'll use this mcp.resource decorator, and then we'll create this URI, or unique resource identifier. So to implement this, we'll just create another Python function that takes no inputs and outputs a string. We have this docstring of example of a three-way intro email, and then we'll just open this file. So I have this folder called email examples, and there's a file in it called threewayintro.md, which is the email template. We'll just open that file and then return its contents. Now, anytime the LLM tries to access this resource, it'll get the contents of this file. And then in a similar way, we can give it access to another email template called call follow-up. So this is the same exact code, just swapping out the URI and the file path that we're accessing, and then doing the same thing for this directory all URI. So this will open up a CSV file, which is filled with contact information. Finally, we'll add tools. So here I'll just add one tool, and it will be one that'll allow any AI application to write email drafts directly to my Gmail account. So I'll start by importing a bunch of handy libraries, and I also have this custom function called get Gmail service. This will set up the connection between the Python program and Gmail. And I won't spend too much time on this code because I talked about it in a previous video, and it's not central to MCP servers. But to kind of show you the code, again, we'll create a tool similarly to how we created the prompt and the resources. We'll just use mcp.tool, and then we have this function. And you can see that we have this pretty detailed docstring. So docstrings are important in all of these different definitions because this is what the large language model has access to and is what the large language model is reading when deciding what tool, resource, or prompt to use. So having a clear docstring is very helpful. And then here's what the code looks like. So first it's going to try to connect to the Gmail service using this function we imported. Then it's going to write the body of the email. It's going to initialize it first, and then body was an input to this function. And then we'll craft who the email is going to, who it's from, and what the subject line is. So both of these were inputs to the function. I'm importing user email from a .env file. And then this is encoding the message so we can send it over the internet to Gmail. And then we're going to create the draft using this code here. So this code was copy pasted from the previous example. So that's why we have a print statement here. This won't be necessary when using in an MCP server because there's no user interface from the MCP client. And then if an error occurs, we'll just say that an error occurred, and then we won't return any draft. Now that we've created the prompts, resources, and tools, we'll need to set up the transport mechanism. So here I'll just do the standard IO, and then we can add this at the end of our Python script so that when we run it, it'll spin up the MCP server. So we're using this .run method, and then we're specifying transport as standard IO. Before trying to connect this to any application, we can just test test it to see if it's working. So if you've cloned the repo, that'll include all of the dependencies and requirements for this UV project. Then we can just simply do UV run, and then we'll run this MCP dev command, and then we'll run MCP Server example.py. So this is the name of the Python script in the GitHub repo, which contains all the code that we've seen this far. MCP is available in the UV environment, and dev allows us to run this server in development mode. And in order for MCP to work, you'll need to have Node installed. With Mac, you can just install it via Homebrew. I'm not sure how to do it in Windows, but it should be pretty straightforward. Once we do that, this GUI will run in your default browser. So it'll have all the resources available in the server, all the prompts available, and all the tools. So we can see that everything we just created is indeed available, and we can click around and make sure everything looks good. We'll see this history of the requests that we're sending to the server. We're just testing and checking if the server actually works and everything we created is available. Once we've confirmed that works, we can integrate it into an AI application. So here, since I'm running it locally, I'll use Claude Desktop. To do that, you need to first have Claude Desktop installed. Next, you can go to the developer settings. On Mac, you just click on Claude, go to settings, click developer. This is what the settings screen looks like, and then you'll click this edit config button, and then you'll paste this JSON schema into the file that appears. And then finally, you'll quit out of Claude and relaunch it, and then you should see the integrations appear. Okay, so let's just walk through these steps real quick to see what it looks like. So here's my Claude Desktop opened up. We can go up here to Claude and hit settings, and then we see developer settings here. So I'll click on that, and then I'll click on this edit config button. This will open up this JSON file. This is like a default JSON file, and simply we paste in all our MCP servers into this JSON file. I'll paste in the code from earlier, and for me, just putting UV by itself didn't work, so I had to put the full file path to my UV installation. So I got that by typing where UV into the terminal. So we're running this UV command, and then these are the input arguments. I'm going to specify the directory where the code from my MCP server is. So that's in this folder here. And then we'll just do run MCP server example.py. The reason UV is helpful is because UV run will basically handle all the environment variables and dependencies that are needed to run this Python script. This is necessary because Claude, every time you launch it, it's going to spin up an instance of this server so that its client can talk to it for all the requests. So we'll just save this JSON file, and then I'll actually quit out of Claude, and then I'll launch it again. And then once we relaunch it, we see that these icons have appeared. So we see MCP tools available, and we have this write email draft from server Ava. And then here is the doc string. This is what is going to get passed to the LLM. Additionally, we have these integrations. We have this prompt from Ava. We have this URI for the directory. And then we have these email examples from the server. I'm going to try to type this prompt. I'll put my name. I'll say I'm an AI educator, add prompt, and then we can pass this to Claude. Okay, sweet. Write a follow-up email to Sarah Chen saying her code looks great. We'll see if Claude can figure out that it needs to use the directory URI from this. So it figured out it needs to use the write email draft tool. So we'll say allow for this draft, and then it created that. Then it said, I've created a draft email to Sarah Chen praising her code. The draft is now saved in your Gmail account. So it seemed like it didn't use the email template, but I guess for Claude, we need to explicitly tell it what resources and prompt templates to use. So let's try again. Let me just say, can you try again? And then we'll add integration call follow-up. Claude's thinking. So it's again using the write email draft. So now it is using call follow-up in the subject line, which is what it should do based on the email template, but it's still adding your code looks great and all that kind of stuff. That's a good caveat. The tools are accessed automatically, but you'll need to specify the prompts and the resources that you want the model to use. If we look at my Gmail, we see that these drafts were indeed created. Here's the feedback on your code, and then here's the second try. So this one's a lot better because this is actually following the email template. So I have like a first line and then like key bullet points from the call and then a closing thing. So I hope this video was helpful to you. If you have any questions, please let me know in the comment section below. And as always, thank you so much for your time and thanks for watching.